Alright guys, today we're going to talk about functions. So we're just looking at what is a function, what makes something not a function, and we're going to look at it in a few different ways, by like charts, graphs, algebraically. So the objective is the student will be able to understand and apply the definition of a function. Okay, a function is a relation between inputs and outputs, okay, where every input has exactly one output. Okay, in equation terms or in function terms, basically for every x you put in, it only gives you one y value. Okay, so if you plug in an x and it can give you two different answers, then well your equation is not a function, it's a relation. Or your piece of information is not a function, it's a relation. A relation is a set of inputs and outputs where an input can have more than one output. So you can put one thing in and get two things out. Okay, that's a relation. For a function, if you put one thing in, you can only get one back out. Okay, 1 to 1. So that's the difference there. So we're going to look at this first set of examples. It says determine if the following are functions. So we're here. Let me just make sure. Okay. Cool. So we're starting right here. Okay. Determine if the following are functions. So I'm looking at this right here. Okay. So first off, when it gives you this set of information right here, these little boxes and the arrows, what you're looking at is x is your input. Oops. And y is the output. Okay, so if I'm putting these four things in, what am I getting back out? Okay, so what you're looking for is you want to make sure that for every one of these numbers, it only leads you to one y value. Okay, so we start at -3. -3 doesn't have an arrow, it's not going anywhere, so you put it in, you get nothing back, fine. If you look at 1 down here, its arrow leads straight to 8, so it has one input and one output. Great. 0 has one input and one input and then only one output. Good. 4 has one input and one output. Great. The -3, which was here, and this 6 over here, they don't have arrows. They don't really matter. We don't really care about it. We're just looking at the arrows right now. So right here, this is a function. Because for every x, there is only one y value. For every input, there is one output. Okay, let's move on to the second set. Again, these are our inputs. This is our output. And we're just following arrows here. 2 goes straight to 1. So that's a 1 to 1. 3 goes to 1. Ooh, and it also goes to 0. So here there's one input, but two outputs. So not a function. This would be called a relation. And then if you look at this last example, again, my input goes to one output, my input goes to one output, my input goes to one output, my input goes to one output. Good. This is a function. Because for each one of these, there's exactly one of these. Okay? Another way that you can tell if a function is a relation is just by looking at a graph. When you look at a graph, you want to do what's called the vertical line test. Okay, so we're down here right now. So the vertical line test is when you look at a graph, if you can draw a vertical line, so a line straight up and down, and if it goes through any piece of the graph and only touches it once, then the graph is a function. Okay, so we'll go ahead and look at some of those examples. Okay, vertical line test. So it says determine if the following are functions. Okay, so we're going to start here, this first graph. So what I mean by the vertical line test is if I draw I draw a vertical line. And let's say I draw a vertical line here, and I draw a vertical line here. I draw another vertical line here and here, all the way through, right? What I'm looking at is how many times does the green vertical line cross my squiggly graph? Well, here it crosses one time, one time, one time, one time, one time. So yes, this is a function. Okay, now again, all I care about is the dotted vertical lines and then my graph. I don't care about the X and Y bars. Like, I don't care about these. They don't matter to me. This is just saying, hey, this is the coordinate plane. Those lines don't matter. The vertical lines can cross those. It doesn't make any difference, okay? So now we're going to look here. Again, I have a squiggly line. I have my coordinate plane, my x-axis, my y-axis. And again, I'm just going to draw vertical lines. I'm going to drop them through this graph. Okay, so you get the idea. Now I'm going to see where they connect. Well, this vertical line crosses here. This vertical line crosses here and here and here. That's not good. So because it crosses more than one time, because this vertical line touches my squiggly graph more than one time, this right here means that it's not a function, because let's say that this x value right here that's in line with this line, let's say that it was a 3. Hold on, let me clear it up a little bit. Let's say that this x value was a 3. And the vertical line that goes with this x value, it crosses the graph in 3 different places. 1, 2, 3. That means for this x value, there's a y value here. Let's say that it was 4, 5, and 6. This means if you want to look at it like we did in the charts, my x value was 3, my y values were 4, 5, and 6, and it went to all of them. So because this happened, it is not a function. So, nope. Not a function. It's a relation. Okay. Let's go ahead and look at this third one down here. Okay. Again, I have my x and y axis. And I'm going to draw my vertical lines. Oh. All right, so as you can see, this vertical line crosses in 2 points. So does this one. We only really need to see that one time, but I just want to show you that it will, in fact, cross at 2 points each time through. So again, a circle is not a function. It's a relation. And then our last one here, go back to green. I can draw vertical lines all over this thing, and each time it's only going to cross at 1 point. So this here is a function. This is actually a parabola, which we have talked about previously. Parabola. This is representing a quadratic function, so f of x equals x squared. Okay? We did a whole lot of stuff with those. But let's move on. Now we're being asked to evaluate each function. Before we do that, I just want to look at a few things here. We have f of x, g of x, p of a, f of x. Don't be intimidated by those things. It's literally just saying the name of the function. So the name of the function here, the name of the function is f. Here, the name of the function is g, and then this is p and f again. And then it's just saying f of x, meaning this is the function, and this is what's being plugged in. Okay. So we're going to go ahead and look at our examples here. Again, it's asking us to evaluate each function. Evaluate. Okay, evaluate means to plug in. Okay. So I have example 1. It says f of x equals x squared plus 3x, and it wants us to find f of negative 5. So if you notice here, I'm looking for f of negative 5. Negative 5 is replacing the x. So wherever I see an x in that function, I have to replace it. I have to plug in a negative 5. Okay, so what I'm going to do when I'm plugging things in, let me just erase this so it's clear. When I'm plugging things in, what I'm going to do is I'm going to leave a set of parentheses so I know that that's where I'm plugging it into. So f of negative 5 equals this function, and I'm replacing all of the x's with parentheses. Inside the parentheses, I'm going to plug in my negative 5. And I have f of negative 5 equals negative 5 squared. Negative 5 times negative 5 is a positive 25. It's positive because the negative is on the inside of the parentheses. If the negative was on the outside, then the 25 would be negative. Plus 3 times negative 5 is negative 15. So we can go ahead and get rid of our plus symbol. And we have 25 minus 15. So f of negative 5 is going to equal 25 minus 15, which is 10. G of x equals 4x plus 2. In example 2, and we're going to find g of z. Okay, it's a z over 2. That's our fraction. Now I know, oh my goodness, guys. Fractions will be okay. We're going to take z of 2, and we're going to plug it in every time that we see an x, which is only in 2 spots here. So g of, I'm going to make it a little bigger so it's easier to see. Z over 2 equals 4. I'm going to leave a set of parentheses, plus 2. Inside the parentheses, z over 2. Okay, so then all we're going to have to do here is simplify. If I multiply this through, g of z over 2 equals 4z over 2 plus 2. 4 divided by 2, this can reduce, and it's going to leave me with g of z over 2 equals 4 divided by 2 is 2z plus 2. Okay, now this is all we're going to get. I'm not going to have an actual number. Here I'm left with an expression. I cannot combine 2z and 2 because they're not like terms. So this is where I leave it, and I'm just going to go ahead and box this whole thing. You don't always get a straight up number as your answer. Sometimes you're left with something that looks like this, and that's okay. As long as you know that you've simplified as much as you possibly could, you're fine. Okay? So let's look at example 3. Okay, I'm going to start by reading it. First off, I have P of A equals 3A minus 5. Find P of 3 plus X. Okay, so the letters switched up on us. Don't worry about it. You're going to be fine. Just know that anytime I see an A, I'm going to plug in 3 plus X. So I'm going to plug it in here, and I'm going to plug it in here. I'm going to rewrite it with my parentheses. You want to make your parentheses a little bigger just because you know you're plugging in 3 plus X, so you're going to need that space. And like I said, I'm going to plug in 3 plus X. Now from here, I do have to simplify, okay? I have to take this 3, and I'm going to distribute. inside the parentheses. So p of 3 plus x equals 9 plus 3x minus 5. Now it's my job to combine like terms. So I have a positive 9 and a negative 5. So p of 3 plus x is going to equal 4 plus 3x. You could also write it as 3x plus 4. That's actually kind of the proper way to write it. Either way is fine. This is what they equal. You can't reduce any further because there's no more like terms. This is what you're left with. Okay. Now I do want to make a note that so far, each and every time we've done this, if you notice, like from example 1, this never changed. And in example 2, these never changed. And in example 3, again, this never changed. You don't worry about the left side. Okay, you can't take p and distribute it and say, oh, it's 3p plus xp. No, that doesn't that doesn't do anything, because everything that I circled, this is the name of the function. Okay, this is the name of the function, and this is the name of the function. And just like your own name, you can't just change it. Okay, it's got to stay the same. Well, technically you could change your name, but it's a long process. It's not worth it. Just keep your name. Okay, so we're going to keep our names here. So we have f of negative 5, that stays the same. G of z divided by 2, that stays the same. And p of 3 plus x, that'll stay the same all the way through. Don't worry about it. Just worry about what's on the right side. Focus on simplifying the right side. Okay? So we're going to look at our last example. We have example 4. It says f of x equals the absolute value of x minus 7. And then it wants us to find, f of x of 1/3 x plus 4. Okay, so it's kind of a combo of the last two. We have a fraction, and we have a full-blown expression here that we're plugging in. But the steps stay the same. Okay, so just like in all three of the previous problems, I know that I have x's, and what I'm being asked to do is get rid of those x's and plug this in. So I'm going to plug it in here, and I'm going to plug it in here, and I'm going to do my best to simplify. Okay, so I have f, I'm going to make a big parenthesis, equals my absolute value symbol. Oops, I need more space. Parenthesis, this is our x, and we're subtracting 7. We have our other absolute value symbol, and I'm going to plug those things in. In both of these parentheses, I'm plugging in 1/3 times x plus 4. 1/3 x plus 4. Now it's our job to simplify as best we can. After I plug it in, I notice that, hey, I have a positive 4 and a negative 7. Those are like terms. So f of 1/3 x plus 4 equals the absolute value of 1/3 x. Positive 4, negative 7 makes a negative 3. I close my absolute value symbol. That's as far as I'm going to get. Can't simplify any further. Like I said, it's okay to have answers like this. Sometimes if they don't give you a straight up answer like they did in example 1 where our answer was 10, sometimes it leaves you with an expression, and that's just fine. So this is the basics of what is a function and how to evaluate it.